it's never been a more exciting time to build software. Developers today have access to incredible building blocks, vast amounts of open source, really powerful AI models, and new intelligent frameworks. But even with all that momentum, the experience of building modern software still has a lot of friction and toil in it. Security expectations are rising, compliance is non-negotiable, tooling is still fragmented. And with the rise of modern agentic applications, developers are trying to figure out how to wire together models, tools, services, infrastructure, just to get started. At Docker, we don't think that this should be the experience. We think there's a better way. Developers should not have to choose between velocity and trust, or between innovation and security, or between building right and building fast. We believe the developer experience should keep up with the possibilities. Secure by default, AI-ready, and built for how developers actually work. My name is Tushar Jain. I lead engineering and product at Docker. And today, I want to talk to you about how Docker is simplifying two of the most urgent shifts in software development. Docker has always been at the forefront of container technology. From the beginning, we've been focused on how to empower developers to build, share, and run software faster and more securely. Today, Docker Hub serves as a window into the global software landscape. With over 11 billion image downloads a month and over 14 million containers, we get a unique view into how modern software is evolving. And from that vantage point, two clear trends are dominating what we see. First, security has become non-negotiable. Software supply chain risk is now a board-level conversation. From code to base images to external libraries, developers are living in a world of dependencies. And vulnerabilities are showing up across this entire chain. Open source is the backbone of modern development, but it's also a growing source of exposure. It now makes up 70 to 90% of an average code base, but only 15% of organizations feel confident in how they're managing this. That's a trust gap, and it's widening. The second trend is the rise of agentic applications, AI-powered systems that can reason, take action, and interact with other tools. We've seen a 130% rise in AI-related image pulls on Docker Hub in the last year. Developers are moving from experimentation to actually deploying in production. 2025 is going to be the year of agents. But the experience today, it's still fragmented. Combining multiple models, tools, wiring up multiple MCP tools, it's all still very DIY. There's a lot of experimentation, and the security and observability is questionable at best. This is innovation with friction. So, how are we responding to these two macro trends? The same way we always have. The problems of composability, trust, and ease of use are what Docker has always solved for, and we'll do that again here. First, so we're going to evolve the Docker platform around two strategic needs. First, securing the software supply chain, end-to-end, with tools that reduce risk and make it easy for developers to work. Second, enabling agentic applications, make it easy to build, run, and trust using containers as the common abstraction. Let me show you what this actually looks like. Let's start with security. When I talk to customers, I hear three things over and over again. Integrity. How do I know that every component in my stack is actually what it says it is? Second, why do you have such a large attack surface area? Why does my application have 700 packages in it that I'm not even sure I use? And third, why are my developers drowning in CVE noise that they don't even know how to resolve or triage? And this is what it looks like in practice. Lots of CVE alerts that developers are struggling to deal with, organizations struggling to keep up with remediation SLAs, and platform teams in the middle overloaded and trying to keep up. We think there's a better way. So today, I'm excited to announce the launch of Docker Hardened Images, a major leap forward in securing your software supply chain. Docker Hardened Images offer near zero CVEs, ultra minimal footprint. These are purpose-built with just the components you need. This results in a 95% reduction in your attack surface area. And they have all the necessary attestations, built-in provenance, SLSA compliance, SBOM statements, making it easy to verify and trust these. And these are compatible with all of your existing Docker workflows. Docker Hardened Images let you start green and stay green. Please join me in welcoming Mike Donovan, who's going to show us how DHI can easily integrate with your workflows.
All right. Hey, everybody. Mike Donovan, VP of Product at Docker. Bringing new products to market is really a special time. It's great to celebrate all the hard work that we put into this, and it's also great to celebrate all the customers who have helped us get to where we are. So let's get into the details of what Docker Hardened Images are. Our catalog of base framework images and application images start with a robust hardening approach. They're extremely minimal images, right? We only include the absolute necessary software required to run the actual application, removing all the bloat that can come from open source containers available today. We essentially are starting from scratch and building up, right, to make sure that it's as hardened as can be. They're secure by default. They have configurations that help you start from a very secure posture, things like non-root users, making sure there's no embedded secrets, and other best practices per application are followed. And then each image that we build comes with comprehensive SBOM and build provenance, and over a dozen other security attestations that are easily accessible through our API and integrated into your supply chain. Next, our images are compatible with multiple distros. We're starting with Alpine and Debian, with more coming soon. This results in a much simpler migration of your existing Docker files to use Docker Hardened Images. Then we offer flexibility through our customization interface. While security is essential, we know that one size really doesn't fit all, and it has to meet your specific needs. Docker Hardened Images strikes the right balance between a lockdown environment that's secure, along with the necessary flexibility you need to incorporate them seamlessly. The types of customizations we support are pretty wide-ranging, things like custom certificates, startup or shutdown scripts, configuration files, and maybe some extra system packages that you need in your specific application that maybe we hardened out. This allows teams to tailor images to their specific needs without compromising security. And when you put all those capabilities together, you get a seamless way to migrate from your existing Docker files and workflows. You can migrate your brownfield applications or start new applications this way. And I know that when you generally try to secure an existing application, it can seem like a daunting task. But with this approach, we think it can become as easy as changing the from statement in your Docker file. And what's the result of all this? You see a massive reduction in critical vulnerabilities, a massive reduction in image size, and this is just one example from our own environment, right? This is essentially a Node application where on the left side, this is what you normally have when you're using the readily available open source Node images out there. There's a lot of CVEs that can be in there, a lot more software that's in there. Switching over that from statement to use Docker Hardened Images Node version makes them all go away. Vulnerabilities go down to 0. The packages required are only 12. These are very small images and much more secure. So I think it's time. I'll show you how this works in more detail. I'll switch over to a little demo here. Let's see if that'll work. Great. Okay, so this is what Docker Hardened Images looks like in Docker Hub. So the other thing to really note is that when you want to use Docker Hardened Images, you access them just like you would any other image in the container ecosystem today, all the images that Tushar talked about. So in here, you'll be able to see a look at the catalog. It contains both base framework images like Golang or Ruby or Java, really any programming language you need, along with third-party application images like Tomcat or Redis or Nginx. And there's a whole bunch in here, right? From messaging queues to web servers to databases, and we're continuously adding more and more images every day, really. When you go into one of these, like I'll pick Node, for example, since that's one that's fairly commonly understood, each image is going to come with an overview of what this image is so that you can quickly understand the security posture of this image. It's going to provide you some guides, how to use this image, right? How you should adjust your Docker file to use this or start from scratch. And then it's also going to give you a look at all the different tags or variants, we call them, available to you to use. And this is all about that seamless migration, right? We have a lot of different variants of images that you can use and incorporate into your applications. There's dev variants and runtime variants. These two variants help you in the event that you do need like a package manager or a shell. That's when you're going to want to use the dev variant. If you're just running like in runtime, you definitely don't need that. When you're actually running these applications in production, that helps reduce your attack surface. We provide both of those. And then we also have variants for each of the distributions, Alpine and Debian, adding more. And then you can also get a quick look at the security posture of these images, what the vulnerabilities are, and the improved security posture. If I were to dive into one of these and I look at like the 24 Debian image, you can see that we've got a comprehensive SBOM, just in a visual representation. You can also get this through an API so that you can integrate it into your systems. But you get a look at the SBOM, you get a look at the build information, so like how this was built, a little bit of the provenance information and the specification so that you can really trust these images. You can also get a look at the vulnerability feed for this specific image. Of course, there's no vulnerabilities associated with this because it's such a small attack surface. And then all those other, there's a ton of other attestations that we attach to these images. Things like of course, the SBOM, the CV feed, the VEX feed, the testing that we're doing, virus scanning that we're doing, the SALSA provenance associated with this so that you can validate the build provenance, and all of this accessible through an API that we'll show. The next step in using hardened images, though, is that it gets mirrored to your private repo, right? So if you're if you have your own Docker Hub organization, you're going to need your own curated version of Node, right? Because you have customizations that are included, and so this is our Docker org, right? And because we're using these images to run our production environments, and so I just want to show you that you can get a look at the same kind of information, right, and all the tags that are mirrored, and then when you go over and look at the attestations for the mirrored version of this, now I can start to look at how this specific image was built. And so it's the same attestations that I was showing on the previous screen, but now I can sort of download these and pull them and look at them, inspect them myself. So I'll jump over to the command prompt here, just run a quick check to download this. And what this is doing is it's using Docker Scout to essentially, which is our command line tool that gives you a sort of an interface into all the security metadata, including vulnerability scans and attestations. And it essentially went and downloaded the build provenance for this particular image. Now, this is a JSON file. I'm not going to force you, I'm not going to quiz you on this. I'm not going to ask you to read through it. But what's in here is really important information about how this image was built, who built it, why it was built, like what commit was the last commit, and more information about the repository that's building it and what its configurations are, so that you can trust that we have the right settings, we have the right build system in place, so that you can accept this into your supply chain. Okay, the next thing that I want to just quickly show is how easy it is to do that conversion process from an old image to a new, from one that was using maybe other variations of Node to one that's using Docker hardened images. So here's a sample application that's just a Node application. It's pretty standard. And it has I have this Docker file, old file, which is using a version of an open source version of Node as its base image. And it's pretty standard stuff. If I run Docker Scout on this to check the vulnerability posture of this image, I'll come back over to my command line. Let me clear this. And I had already previously built this image with this particular tag so that you don't have to watch the build process. But using Docker Scout, I can assess the vulnerabilities of this image. And this is actually going to take a couple seconds here because this is a big image, right? I'm using the open source version of Node that has a whole bunch of extra software on it, a lot of bloated software that's unnecessary. It's the 700 package version instead of the 12 package version. But what it's going to do is go look, scan all the, what Scout is doing is scanning all those packages, trying to assess what vulnerabilities are associated with them, and then providing you a list of those vulnerabilities. And as you can see, there's a lot of them, right? This is not a very secure image. It's a trusted source of Node, that's good, but it's not very secure, and it's also quite large. If I scroll all the way to the top here, you can just sort of see how many packages and the size. So not the best, right? But if I were to go back over to the converted Docker image using our Docker hardened image versions, we're going to see a very different story. So here the Docker file looks a little different, right? We're actually, to showcase the power of hardened images, we converted it to use a multi-stage build, it's called. So there's 2 stages. You'll see that at the top here, it's using our dev variant. And we do this because the dev variant is what you're going to use to like build your source code as part of your Docker file. You'll see that it's got npm included. That way you can run an npm command. But when you are actually running your Node application in production, you don't need npm. You don't need Python. Python comes with Node, for those who didn't know. You don't need all those things. And instead, you just need the basics requirements of Node. And that's what this second stage of this Docker file is doing. It's just copying essentially the source from the first stage into the second stage and only using the very minimal amount of software needed. So if I go back over to the terminal and let's change it to be the tag that is actually running using Docker hardened images. And if all goes well, you should see 0 vulnerabilities and a massively reduced count of packages. But it's doing the same exact thing. And there it is, right? Much smaller image, much lower package count. It's not 12 packages like I showed in that screen because the software added some other packages on top of it, but it's massive reduction from what it was before. Okay. Let's see. I'm going to go back to, I think this will work. There we go. Okay, great. So that's how Docker hardened images kind of works end to end. It's really that simple to do this conversion process and really improve your security posture with very little work. I think that the other part of hardened images in our strategy here is that hardened images are really just the start, right? We think that they're the beginning of a larger strategy around incorporating these and securing your entire supply chain. And I think to really do that, you have to seamlessly integrate it into your entire DevOps stack. And so I'm really pleased to welcome Toddy Mladenoff to the stage to help show how Docker hardened images integrates seamlessly with container security from Azure.
Thank you, Mike. Your demo is much more impressive than mine. Thank you, everyone. My name is Toddy Mladenoff, and I've been doing supply chain security for containers at Microsoft for the last almost 4 years. The way that we look at the supply chain at Microsoft is we split it in a couple of stages, as we call it. So the first one is you acquire image from somewhere outside. A lot of our customers, they are very conscious. They kind of they trust companies like Docker or other companies that are producing images. However, what they want to do is they want to actually validate those images before they start using them internally. And in my demo, actually, we'll go through kind of this validation step, building it, and also deploying the image on AKS. And you can see what controls we have put, for example, in Azure services, so you can actually provide much more secure deployments. And also, you can see how you can leverage the Docker hardened images in Azure in order to ensure that there are no vulnerabilities that you are deploying on production. So I'll switch to my machine now, and give me a second to make sure that it's up and running. And we'll go through the demo. OK. Before we actually start with the Docker hardened images, let's look at one example, as Mike already showed, one existing example. So I have this Docker file that uses Python Slim image. I already built that image before the demo, so we can avoid kind of the build step. But let's take a look at this Python or application image that is built on top of Python Slim. So I'll run Trivy, and you will see that Trivy will report 109 vulnerabilities in this particular application image. I will actually try to go and deploy this image on my AKS cluster to see what will happen. So I go and create the namespace for this demo. I do a deployment, and you get an error. And initially, you'll think, OK, why am I getting an error? It's a brand new image. I just built it from Python Slim. It tells you immediately. So this image contains one high or higher CVE, which is more than a load count of 0. So we have a feature in Defender, which is called gated deployments. And apologize, apparently my session expired. Let me get to that screen. So if you go in Defender, if you go to environment settings, security rules, and you see that there is gated deployments for vulnerability assessment. And I will just filter to my gated deployment. So this is the one that I created as a policy. And let's take a look at the policy. So this policy has deny action, which means it denies everything that doesn't match the policy. I apply this policy to my AKS cluster, and the policy says that I do not want any images that have vulnerabilities high or critical in them. And as we saw on the example, the image that I tried to deploy had 109 vulnerabilities. There is a good chance that one or two or more of those are high or critical. Now, as I mentioned, one of the things that, and you can see that there are no pods running, just to make sure that there is no some tricks behind the demo. So as I mentioned, what we advise our customers is always verify the images before you use them internally, whether that's for build, whether it's for deployment. You need to make sure that you trust that image. And thanks to actually all the attestations that Docker adds to their hardened image, we can do a much better verification of those images before we start using them internally. So what we do in this particular demo is we use ACR tasks, which automatically goes and pulls the image from the Docker Hub, verifies certain attestations, and you can write all kind of verification that you want or match your company policy. And only if these verifications are passing, only then we copy the image inside our ACR, and we can use this image to build our application image. So run the task right now. It will take a while. First, we need to spin up the task. And after that, inside the task, so there are actually two things that are happening in this task. The first is we run verification of certain attestations. And you can see right now that we are checking vulnerability attestation from Docker. We are checking the SALSA VSA attestation from Docker. We are also checking the Docker provenance as well as SALSA provenance attestation. And we are checking the SBOM. We do, you can do verifications inside that are not only the signatures and that those come in from Docker, but you can do also verifications to say, I, for example, do not accept certain licenses. So if there is a package with a certain license in the SBOM, I may actually decline this image and not allow it internally. We do two verifications for this particular image because this is a multi-arc image. For our build, we will use only one of the architectures. But you can verify a whole set of images. So everything passed. So if you see all the verifications passed, and now we are copying the image from Docker Hub into our ACR. And switching to ACR, and thanks again for the session. Okay, this is the ACR, and this is the repository, and you'll see the Docker hardened image is imported in our ACR. Now we can do the build directly from our ACR, and we are completely independent from any external dependencies. However, we leverage this secure image that we get from Docker Hub. Just to show you that actually we did not copy only the image, but all the attestations in it, we'll run a tool called Auras, and this is an open source tool that is intended to actually work with OCI registries or container registries like ACR. And you can see that not only the image, but all the attestations are copied together with the image, which means that later on, you can use also policies to act on those attestations, not only when you ingest them, but also after that. And now let's build our application image. That should be pretty fast because the Docker hardened image is very small. This is happening quite fast and easy. Once we build the application image, let's take a look at what Trivy will tell us about this application image. So once again, this application image is now built on top of the Docker hardened image. As you can see, there are no vulnerabilities in this application image. Let's go ahead and try to deploy to AKS. Deployment succeeds. So the policy pass, there are no vulnerabilities, and we can see the pods running on AKS. So going back, just to recap, our recommendation for customers is really to make sure that they validate everything before they use it. However, we are very happy to see Docker actually coming with these hardened images. One of the problems that we see most often internally in Microsoft, as well as for our customers, is dealing with vulnerabilities that the developers don't have access to fix. And 90% of the time, those are the vulnerabilities that come in the operating system. Hardened images will really help the whole industry actually get much better and reduce the vulnerabilities that they deploy on their cluster. So great job from Docker, and we are really happy to see them actually starting this. Mike, back to you.
Awesome. Okay, thanks, Toddy. That was great. It was really, I just love seeing how easily it is to integrate Docker hardened images into the Microsoft's leading container supply chain stack overall. We're going to continue to expand this ecosystem by integrating with a whole host of partners like Sonatype and Wiz, further strengthening our ability to integrate seamlessly into your DevOps stack. And one final note before I hand back to Tushar is I just want to say thank you to the team who's been building hardened images, working night and day to make this happen, along with our customers, right? We couldn't do this without them. They've been really guiding the way here, and we look forward to growing this product even more. I'll hand it back to Tushar.
Mike. Thanks, Mike. Thanks, Toddy. Just to reiterate, what I really love about the talk track and the demo, Toddy and Mike, you both showed, is just how easy it was to take something that used to be so complicated, security attestations, provenance, compliance, and it just fits easily into existing workflows. The best demos on our mind is when it actually just feels a little bit of, you don't actually have that aha moment because oh, it just worked. I don't have to do much else. I just changed one thing and everything just worked. That's sort of our goal with Docker hardened images, is real security built in from the start without the friction. So if you're looking to secure a supply chain, Docker hardened images are your new baseline, and this is available today. All right. Now let's talk about the second major shift we talked about that we see. The era of agentic apps is here. I have not been to all the other talks, but I'm willing to bet you're hearing about agentic applications all day today and throughout this conference. And that's because this is real. We're entering a new phase of software where applications become deeply intelligent, they reason themselves, they control the control loop, and they take autonomous actions. These systems compose models, tools, and services to interact with real world in intelligent, goal-driven ways. Imagine a product manager agent that monitors customer feedback, deeply understands what the user actually need, understands your product and your technology stack well, and then proposes the next steps and new features to build and the next roadmap all autonomously. This isn't experimental anymore. The pace of innovation is accelerating. Every company is figuring out how to bring agentic experiences into their products. And that means every developer is now starting to build agentic applications. Agentic apps can be built in many ways, but a few core components are emerging as standard. First, you need models that are capable of reasoning and understanding complex inputs. These might be running locally, might be running remotely, or a combination. In particular, I think it's really interesting to observe the growth of open source models. Open source models are no longer experimental. They're going to be part of everyone's agentic stack. And the future of agentic applications will be closed source, open source, all of it together, which means we have to also solve for open source models as part of your experience. These models then need to interact with tools, services, tools, etc. And MCP has emerged as the new standard here. It's gained quick traction across the ecosystem, and it's quickly emerging as the standard. Together, these components allow developers to build powerful intelligent systems that can perform tasks and take actions. But getting all of this to work easily is still a challenge in the developer workflow. There's still a steep learning curve and a lot of toil. Sorry. The potential is here, but the experience of building agentic applications, it's still evolving. And when I talk with developers building this, there are a number of challenges I hear again and again. So let's talk about what those are. First, the learning curve. There's just a lot to figure out. Understanding the core concepts of models, understanding how to wire up tools, understanding how to put all this together with an agent. Developers just want to start building fast, but the friction to getting there is still high. There's just a ton of boilerplate involved and a lot of experimentation. Developers I talk to are asking, what's the right way to set this up? How can I have the same thing run in my machine, in CI, on my teammate's machine? How do I package my model, my tools, and my app in a way that's consistent across my entire environment? And there's also real need for composability, because agentic apps are inherently made up of parts: models, tools, services. And you need a clean, modular way to wire these things together. And today, there is no standard. Everyone's sort of figuring it out on their own. Once you figure out your architecture, the next challenge is finding the right tools. There is no single trusted place today to discover tools that are production ready and secure. Developers are asking, where do I find these tools? Which ones are verified? What does each one actually do? And can I trust it in my stack? And even when something looks promising, there's still a lack of clarity on how well it'll work. Will it work on my machine? Will it work in my CI? Will it work on my teammate's machine? This friction slows teams down. Even if a tool looks safe, what happens at runtime? These tools aren't passive. They take action, they read production data, they call other APIs. But the security model around these tools right now is ad hoc at best. Some common issues we hear: rug pulls, tools that behave one way during testing, but then at runtime change behavior once deployed. Prompt injection or context poisoning that manipulates the tool behavior. And then a lack of auditability. It's just hard to tell exactly what ran, when, or why, and what it did. The blast radius of a misconfigured or malicious tool is very real. And as these systems gain more power and are deployed in production systems, the need for trusted tools, scoped access, and clear observability becomes non-negotiable. Containers brought simplicity and structure to modern software development. We believe they can do the same for agentic app development. Developers ask us, why can't I just pull and run a model? Why can't I just pull and run a tool? Why can't I just pull and run an agent? That simplicity, the power of pull, run, up, that's what made cloud computing take off. Now it's time to bring that same developer experience to agentic development. That starts with trusted content. Docker is the go-to source today for trusted container images. We're now going to bring that same trust, structure, and simplicity to the world of agentic applications. we recently launched the MCP catalog. This is a catalog with a curated, verified collection of MCP tools that follow clear packaging, versioning, and security standards. These are tools from leading providers, GitHub, Stripe, Slack, and many, many others, built to work with agents out there. And right alongside it, we're expanding our model catalog on Docker Hub. This is a place to find and pull and run open source models like Phi, Llama, Gemma, DeepSeek, and many more. Together, these catalogs form a trusted foundation for agentic systems, just like the container image ecosystem did for services. So if you think of Docker official images, you now think of Docker MCP catalog and our Docker model catalog. Discovery is only the first step. Once you find the models you want to use, we need to make it easy to run them securely and predictably wherever you're working. All the models in our catalog and all the tools in our catalog are packaged up as containers and run in containers. This means you get consistency across the environments, you get sandboxing by default, and just a clean separation of concern. MCP tools are run through an MCP gateway that ships with our toolkit. This is a lightweight runtime proxy that handles communication between your agent and the tools. This allows us to inject critical capabilities like secret management, security rules, audit logs, observability, without you having to code all this up yourself. When you use models or tools from Docker Hub, you're not just pulling a container. You're getting something that is secured, composable, and ready to integrate. Let's take a closer look at how this works, and starting with open source models. With the Docker Model Runner, running an open source model locally is just as easy as running a container. It's just Docker Model Run. It's the same tooling you already know and you're familiar with. And that means this also works with you everywhere you already use Docker, your laptop, CI, and beyond. That's the simplicity we're trying to bring to agentic app development and the portability we think that's needed here. We extend and continue this with MCP tools. So similarly, to use MCP now, it's just Docker MCP. Using a simple command with the same tool chain you're already familiar with, you can pull verified tools from the MCP catalog and connect them via a gateway to MCP clients without you having to wire up anything yourself. Use standard Docker commands, just like with models, and this works consistently across the environment. Okay, so we talked about trusted content and how we make it easy to use open source models and how we make it easy to use MCP tools. But agentic applications need composability. They need to wire all this up. So I'm really excited to show you how we bring all of this together with Docker Compose. Millions of developers already use Compose. Compose has been used to define and orchestrate multi-service applications. It's declarative, portable, and battle-tested. We're now extending that same system to agentic applications. That means you can now easily define your entire agentic stack in a single Compose file. Models, MCP tools, services in a single file. You choose what model you want, what tools you want, how they should be wired together, what security rules you want, what observability you want, and we make it easy to plug all that in via Compose. We've introduced new Compose providers that plug into our model catalog and our MCP tool catalog, so you can easily reference the trusted content that's there in Docker Hub into your application via Compose. You need to log every request, just add a flag. You want to limit the scope of a tool, just add a flag. It's all configurable and fully extensible. And at the center of all of this is your agent that takes input, does the reasoning, calls tools to get the job done. But you get security, observability, and easy composability out of the box. And so from a single Compose file, you bring up your entire agentic system, all working together, just as Docker Compose up, as simple as that. Okay, we covered a lot right now. We talked about trusted content, secure execution, and composable agentic apps. What ties all of this together is simplicity. Pulling a model, running a tool, running an agent. All of this is using existing tool chain that you already know. And it's key to how we're making agentic apps developer-friendly. So let's bring all this to life. And once again, please welcome Mike back, who's going to show us how this actually works in a real workflow.
Thanks. Okay, back to the demo. Let me get set up. Okay, great. All right, so a little context before I start showing compose files and running stuff. I'm a product person, and what does that mean I do every day? I attend meetings, way too many meetings, and I barely do any real work, right? One of the tasks that I always need more time to do, which I never get enough time to do, is understand what users are telling me, what I'm hearing from the community, and how to synthesize that into actual things we should build. So whenever I'm strapped for time now, and I'm assuming a lot of you are thinking the same thing, I want to figure out how AI can help me get more time back. And so that's what this demo was all about, right? This is a sample GitHub project. This is my project that I need to understand what's going on in the community of the user base. It's the Turbo encabulator. I'm sure everybody has one of those at home. And I want to understand what all the users are telling me, what the feedback is, what my feature requests are, what my bugs are, what issues are happening out in the community. So I'm going to show you an agent that essentially does all that and summarizes it for me in a way that I can take action on. Now, I find that it's really helpful to visualize how these agent architectures work, and then this kind of reflects exactly what you'll see in the compose file. And I think this is kind of going to be a standard approach to just building agentic applications. So it starts at the top here with a coordinator agent, right? This is an agent that essentially is the boss, it's the manager. It delegates work to other agents that are empowered to take on certain tasks. The first agent that it delegates to is a GitHub agent. This agent is powered by a cloud model, right? It's using O3, I believe. And then it also is given some of the powers from our MCP gateway and tools to interact with the GitHub API, right? It has a whole list of different tools it can call from our MCP gateway. The next agent is the Notion agent, right? Because we use Notion to sort of summarize a lot of product requirements. So we need an agent who knows how to speak with Notion and interact with that API. It's also using a cloud model and interacting with the MCP gateway from our toolkit. And then the final agent is a summarizer agent, right? And this is using a local model, using Docker local model runner, as well as our MCP gateway to understand how to interact with the data and summarize it. And then all that comes together and should result, and the coordinator agent is pulling all that stuff together. Okay, let's go over to the compose file. So this is a sample project, compose agents demo. And I'm going to walk through the structure of this compose file a little bit so that you understand how this works, and then we'll run it. The first thing, just top to bottom, you'll see is the definition of our MCP gateway. Recently, we enabled, we created an ability to extend compose, right, to have custom providers. And so one of these extensions that we've created is an MCP gateway extension. And this really just abstracts away a lot of the work to integrate with the MCP gateway. And so what you're specifying here is that this architecture needs the MCP gateway, and it's going to allow certain tools to be called that are from our catalog. And this is kind of the first line of defense with just securing these agentic apps, because these tools can be pretty powerful, and you need to only allow for trusted tools to be used. So this list is in code, checked in, reviewed, and it makes sure that you only are using the tools that you believe it should be using. It's also got some other things that are options that we've added to this gateway, like whether or not it should be auditable and logging all the calls, whether it should be scanning for secrets and then blocking them if they're, if any of the prompts or any of the data returned back from the tools might contain something secret. We don't want to allow that to happen. And then we also want to make sure that the tool is exactly who it says it is. You verify the signature of that tool, and that way it doesn't impersonate anything. Now, this MCP gateway is actually connected to the toolkit that's available in that's available in Docker Desktop if you go over here. Now for anybody who's used, this is Docker Desktop. For those who don't know, I'm assuming all of you are fluent in this tool. But you're able to look at all the different MCP servers that are accessible as part of our catalog that you can easily just configure, right? We have over 100 different tools here to choose from. A lot of Azure and Microsoft-based services. GitHub is here, Azure, and there's a whole bunch of other things. I've configured around 6 of these to be available to my agents, right? Now, the configuration is one thing, the availability, enabling it is one thing, but then the other really cool aspect of our MCP gateway is that you can centralize the configurations needed to use these servers, these MCP servers. And that's like a very common pattern, right? I want to interact with Notion. I want to interact with GitHub. Well, the first thing you need is an API key. And the worst thing is if I had to copy and paste that all over my local file system or my code base and configure it in multiple places, our toolkit allows you to do that in one place, in a very familiar place that you're already used to. So all that's configured here. All right, let's go back to the compose file and keep going. The next part in the compose file is the large language model. This again is using a extension of compose, a new provider that we've added. That's the type model. This essentially interacts with Docker Model Runner and runs this model locally, and we just chose one out of our catalog. And then there's the agent configuration. Now, these agents are just regular old Docker images, right? And they're using an SDK that, they're using an SDK called Agno that it's really flexible sort of agent framework, but you could insert any framework that you want for different agents, any SDK that you'd want for agents, because it's just a Docker image, and it runs like anything else. So there's 2 images here, one for the actual like back-end agent, and then also a UI that comes with the Agno open source project. I'll show one more thing before we get into the demo. It's this agents configuration. And this is really powerful because it allows you to sort of declaratively specify what the agents are allowed to do and how they should operate. And again, you just have to think about this as a new paradigm when you're building these agentic applications. So just like in that diagram I showed, there's a GitHub agent, and it has some instructions on how to behave. What kind of job is it meant to do? You have to prompt it. You have to tell it that. And then you're also giving it a set of tools that it's allowed to call. So it's another line of defense as you were about giving your agents access to only the tools that you want it to have access to. And then you tell it what model to use, right? Every agent needs a brain. That's what the model does. So there's the GitHub one, there's the Notion page creator, it's following the same kind of format. The writer, I called it summarizer in the image, but this one is using our a locally run model using Docker Model Runner. And then if I scroll down a little bit more, you'll see the coordinator definition here. And all this is doing is saying, similar, it's an agent configuration, it needs a model to run, but then it also says who are my agents, my other members that I can delegate to. And that's kind of the basics of this thing. All right, so now jumping over to how we run this, right? Like this is always the wow moment, I think, whenever I'm doing this, is because of how easy it is, as Tushar was saying, to actually now run this whole service, run this whole application stack, right? I did Docker Compose up here. I'm going to load up a couple things. This is basically started all my containers. We're going to go over to Docker Desktop so that we can watch the log of this agent. I'm going to kind of walk you through what's happening. But so that's all loaded up, right? And then if I go over to the browser, I'll get this is the Agno interface. Again, use any agent SDK that you want. It's fine. And just lay of the land here, I'm interacting with that one coordinator agent, and I'm going to basically tell it to do some work for me. Let's copy a prompt here so that you don't have to watch me misspell anything. But here's the prompt that I'm going to tell it to do, right? I want you to summarize issues from that particular GitHub repo and post a summary to Notion, right? So that's all the instructions there are. It's a very non-deterministic system just based on the prompt that I specify. So let's run this. Let's jump back over to Docker Desktop so we can watch the logs happen. And then let's also pull up our CPU monitor here just to see what kind of engagement we're getting with the GPU, because that's always kind of fun. So I'm going to try to be a little sports commentator as the agents are doing their work. Right, so this was the loading of the compose file. Now the agents start to kick off and it receives a session, right? It receives a request from me to actually do some work. And you can see how it's loading in the coordinator agent and telling it what its instructions are, right? You're the leader of this team. You have to give it these kind of prompts. And here's your agents and how we want you to respond as a coordinator. So you're in kind of control with those instructions. It receives my prompt, okay, and then it starts analyzing that prompt to come up with a plan on what tools to call. Okay, it's going to then go and figure out that it needs to call the GitHub API. I didn't tell it how to do this. I just made it available to call the GitHub API through the MCP gateway. And it's going to go and start making those calls here. And down, keep going here. You can see that it made the calls to list out the issues from GitHub. It's basically showing us debugging the response from the API. Awesome. Let's keep going down. Let's see how far it's getting. This is like pretty printing the JSON that I got back from the API. Keep moving, keep moving. This is getting more information now, right? Again, I didn't tell it how to interact with the GitHub API, but it knows that it's going to get a list of issues and then try to get more information and details. The body excerpt is there, as you can see now. Just keep going. Okay, so now I think it's still getting some more details. Okay, so now it kind of stopped getting all the details of the different GitHub issues over here that it needed at the top here. And now it goes on to the next step where it's going to summarize these. And this is interacting with that local model. And it's sending in all the GitHub issues to the summarizer. And this is how it's summarized. You can see that it summarized it. And this is the kind of markdown syntax that it's summarized with. It looks like I missed the GPU spike, but it generally it was interacting with the local model. And then it's again summarizing. Let's see if it went to the Notion. It should then go and interact this with send this to Notion. And let's make sure this looks like it's calling Notion. Yep, it's making the call to Notion now to go and post this to Notion. And whenever I start to see emojis, I know it's kind of working because that's how this works. That's how our summarizer works. And let's just keep going down. Calling tool API. Tool call. Great. Okay. So now it looks like it wrapped up, right? It was able to summarize the issues, post it to Notion, and then print this out. If I go over to the agent UI, it'll have returned back with just a simple text that says, I summarized the issues for you. You can load this up, and this is what the summarizer decided to do. Right now, it's interesting. There's always different output from each of these that we've gone through a couple times. Some are better than others, and it all really does depend on the kind of model that you're using to summarize. Now, there's one more part that Tushar mentioned around security with our MCP gateway. So one of the things that maybe you saw in that log that we were doing was checking for secrets being passed around, right? We configured that in the compose file. So we created another agent configuration here, another coordinator that I'll just show it real quick down here. That's this GitHub team. And it essentially is configured with this checker that checks to see if there's any secrets being passed to or from the tools. And so I just selected that other coordinator. And let me go and send it another prompt just to show how the security checking works. What this prompt is doing is it's going to go and grab this particular file. Now, you can take a screenshot. It's disabled, so if you try to use this pad, it's not going to work. But it's just to show the secret, right? Just to show how a secret could be accidentally pulled into your MCP gateway or your agent flow, and then you wouldn't want that to leak out. So it's going to pull down this file, or it's going to try to at least. And if we go again, let's go back to here and let's see what it's doing. We should start to see that, yeah, there we go, right? So it tried to fetch it, tried to download it, but it can't. It's seeing this error because it is seeing a secret that's going to be returned. And it does try a couple times, right? That's the other thing about agent workflows is it tries to recover, which is in some ways can be really good. In other ways, it can go through a couple cycles. So you can tune it for that. But eventually it will say, it's sorry, I can't share that. It's nice of it to apologize. And that's really how the security, one of the areas of security works. There's a lot more we plan on doing with the MCP gateway and the security checks that we can put in here to really make MCP gateways handle a lot of the different attacks Tushar mentioned. And I think it kind of worked. Okay.
Good job. Thanks a lot, Mike. I don't know about you all. I find that really exciting. Just taking really complex stuff and making it easy. I always find to unlock innovation. This is why I personally love working in developer tool space. You unlock innovation and all developers can just go build amazing applications. And what Mike just showed was taking really complex stuff and making it really easy. So this is the start for us. We're going to be doing a lot more here. I'm going to give you all a short preview of just stuff we plan to do in the future here very soon. Watch this space. So one of the things we'll do is we're going to expand Docker Hub to become the place for agents, the same way it is for images and tools and models. Tomorrow, not tomorrow, literally, sometime soon. My team will kill me if I say tomorrow. You will see agents on Docker Hub. It'll be easy to you'll be able to share agents there, deploy them, pull them, run them from there. We will also make it easy for you to use cloud in your inner loop. So you'll be able to do something like Docker Cloud Start and then Docker Compose up. So if you don't have GPUs locally or don't have enough GPUs locally, you can still get the inner loop fast experience by just embedding cloud in your local experience. Also will be coming soon. We'll have to talk to you more about that. Let's take a quick step back. We looked at two major shifts happening across software development today. First, securing the software supply chain. Docker hardened images give you and your teams a clear minimal foundation, something you can trust from your first commit to production. Second, we looked at the rise of agentic applications, where we need models, tools, gateways, and intelligent workflows to come together in a way that's secure, composable, and with a clean developer experience. What ties all of this together, and what Docker's always been focused on, is simplicity, trust, and developer experience that just works. Our mission at Docker is to make the shift to a secure, AI-accelerated development not just possible, but also simple and with a good developer experience. We're around. I'll be hanging out afterwards outside if you would like to talk. We're also at our booth, booth number 400. Thank you all so much for joining us, and really excited to see what you build with this. Thank you.